Okay, so I want to do number 9D here from the example handout, not from the homework. Um, so in this one, it's a cotangent function. So we got to do two things. First, let's get it into the form that we've been using for everything else. So that's going to be 3 cotangent 2x minus pi over 2 minus 2. I have no idea why I wrote that horizontal or slanted. Anyway, okay, so we've got that. It's a cotangent function. So the other thing I want to do is I want to sketch a really simple sketch of cotangent. And so here's my y-axis, here's my x-axis. I'm going to sketch one period of it, and I'll sketch the first period that we normally look at, which is between 0 and pi. And here, and it crosses, it does kind of the opposite of tangent in a way. It does this thing where it crosses at pi over 2. And then if we go to pi over 4, we're at 1. And if we're at 3 pi over 4, we're at negative 1. Okay. So now what we need to do is all our shifts and stretches and everything. And remember, it keeps repeating. So it's not just that one spot that it does that. But I mean, if we can graph one good chunk, then we can just repeat it over and over again anyway. So 3 cotangent, all this other stuff. So vertical stretch will be 3. The period, we can figure out because we know that b equals 2. And normally, remember, the period we get by doing 2 pi over 2. But the reason we've been doing 2 pi over our b is because 2 pi has been the period of our parent function sine and cosine. But now we've got a parent function of cotangent. So that period is just pi. So we're just going to do pi over whatever b is. So in this case, it's 2, so it's pi over 2 is the period. The vertical shift, let's see, we've got 2 units down. And then the horizontal shift is going to be pi over 2 to the right. Okay, so let's take a look at what this does to our numbers, right? So vertical stretch of 3 means instead of negative 1 to 1, or instead of this being at negative 1 and that being at 1, it's going to be at negative 3 and positive 3. But then I shift everything down 2 units. So really, it's going to be at 1 here and negative 5 here, right? The period is only pi over 2, not pi. So that means everything's got to get squeezed inwards. So where this used to be at pi, now it's at pi over 2. So everything I'm cutting in half, essentially. So pi over 2 becomes pi over 4. This becomes 3 pi over 8 instead. This becomes pi over 8. Okay? And then I got to shift everything pi over 2 units to the right anyway. But if you think about that, shifting it pi over 2 units to the right shouldn't do anything, should it? No. Yeah, if you shifted pi over 2 units to the right, you get the same exact graph you started out with, don't you? No, you don't. Sorry. My bad. The original graph is cotangent, which looks like this. So this asymptote has to get shifted to... Oh, no, yeah, you should get the same thing. I don't know what I'm talking about. I'm sorry. Okay, so... so our final function here is this picture. Let's see. So we just need to graph this accurately. Okay, so I have the lucky ability to be able to erase my axes easily, but you don't. So I'm going to erase that axis right there and just move it up, because here's 1 and here's, whoa, here's 1, and here's negative 5, and so it's going to be roughly here. And then the point that's now in the middle of negative 1 and 5 is going to be negative 2, so this point here is pi over 4 comma negative 2. This point right here is 3 pi over 8 comma negative 5, and this point right here is pi over 8 comma 1. And let me just double check to make sure all that works. And it does. Good. All right. Okay. Hope that helps some. And this is going to be similar to several of the homework problems as well. All right.